One organ inside you may already be a decade older than the rest of you, not metaphorically, biologically, measurably. A study out of Northwestern Medicine analyzed organ-specific aging clocks across thousands of adults. What they found rewrote a fundamental assumption of medicine. The body does not age as one unit. It ages organ by organ, at speeds that have almost nothing to do with each other. Most people have never heard this, because the medical system was not built to look for it. Routine bloodwork measures disease. It does not measure age. Those are not the same thing. By the end of this video, you will understand something that most doctors have never been trained to look for. But the most disturbing part is not what the study found. It's what they found when they looked at who it was happening to. In 2023, researchers at Northwestern Medicine published findings from one of the most comprehensive biological aging studies ever conducted. They used protein biomarkers in the blood, over 1,000 distinct proteins, to build individual aging clocks for 11 separate organs. The data set, nearly 5,700 adults between the ages of 20 and 90. What they found was not gradual, uniform deterioration. In 18.4% of participants, nearly 1 in 5, at least one organ was aging dramatically faster than the rest of the body. Not slightly faster, dramatically faster. The heart, the brain, the kidney, the liver, each on its own timeline, each telling a different story. And in the majority of those cases, the person had no symptoms, no diagnosis, no reason to believe anything was wrong. Right now, inside your body, 11 different clocks are running. The question the Northwestern study raised, and medicine has not yet answered, is whether anyone is reading all of them. The researchers cross-referenced their aging data with long-term health outcomes. The results were unambiguous. Accelerated aging in a single organ, even just one, significantly elevated the risk of disease and death, independent of the body's overall biological age. But that's not the part that should concern you. The real question is, what is driving one organ to age faster than the others? And the answer is something the body has been signaling for years. Think of your body's aging not as a clock, but as 11 clocks running on the same battery, except some clocks have a faster gear mechanism built in, and the gear can be sped up. Each organ has its own population of cells. Each cell manages its own protein production, its own inflammatory signaling, its own repair response. When that repair response begins to lag, the organ's proteins start to change. The Northwestern team could detect those changes in the blood. The heart ages fastest in people with high cardiovascular risk factors. The kidney shows acceleration before clinical kidney disease is detectable. The brain shows protein shifts associated with accelerated aging, up to a decade before cognitive symptoms appear. A decade. The liver, which regenerates more aggressively than almost any other organ, still showed accelerated aging in participants with metabolic dysfunction. Regeneration and aging are not opposites. They can happen simultaneously. An organ can be repairing itself and aging faster than it should at the same time. The connective tissue degrades. The vascular supply becomes less efficient. The inflammatory load increases, and the organ downstream absorbs what it was never designed to sustain long-term. The Northwestern team found that accelerated heart aging increased the 5-year risk of heart failure by more than 2.5 times, even in adults who had no existing cardiovascular diagnosis at the time of measurement. And here is where the story becomes structural, not individual. The tool that detected all of this, a proteomic blood panel, costs less than a standard MRI. It exists. It works. It has been validated across multiple independent cohorts. It is not part of any routine physical examination. It is not covered by most insurance plans. It is not something your doctor will order unless you already have symptoms, by which point the accelerated aging has been underway for years. Here is where the story gets uncomfortable. The failure is not a person. It is a system, and the system has a specific shape. Medicine in the United States, and in most of the developed world, is organized around specialty.
A cardiologist watches the heart. A nephrologist watches the kidney. A neurologist watches the brain. Each specialist measures their organ in isolation, using the same panel of markers that have been standard since the 1980s. None of those standard panels measure biological organ age. They measure dysfunction after it has already caused damage. The gap between accelerated aging and clinical dysfunction can be 10 to 15 years. That gap is where the opportunity disappears.
In 2022, a separate team at the Karolinska Institute published a study of over 44,000 adults across 4 countries. They found that accelerated aging in multiple organs, what researchers now call agiotype clustering, was more predictive of all-cause mortality than any single cardiovascular risk marker currently used in clinical practice. Your doctor runs a lipid panel, a metabolic panel, maybe a thyroid screen. None of those tests tell you how old your kidneys are. None of them tell you whether your brain's protein signature is tracking 15 years ahead of the rest of you. The test that would tell you those things, a SomaScan proteomic panel or equivalent, runs approximately $200 to $400 out of pocket. Insurance classification codes for preventive proteomic aging panels do not exist in the current coding framework used to determine coverage. This is not an oversight. Coverage classifications require lobbying, clinical trial pressure, and guideline adoption by major specialty societies. Those processes take decades and require financial incentives that preventive testing does not generate. Treatment is reimbursable. Prevention, at this level of precision, is not. The system is not designed to find the problem before it becomes expensive to treat. And what researchers found when they looked at what could actually change the trajectory, the answer challenges almost everything medicine currently tells people to focus on. The Northwestern team did not just identify accelerated aging. They identified which biological mechanisms were driving it. And 3 of those mechanisms respond to interventions that already have significant evidence behind them. The first is glycemic variability, not average blood sugar. Variability, organs exposed to repeated spikes and crashes in glucose, show accelerated protein degradation in ways that a standard HbA1c test does not capture. Continuous glucose monitoring studies show that glycemic variability predicts organ-level inflammation better than fasting glucose alone. The second is VO2 max, the body's maximum capacity to transport and use oxygen. A 2022 Cleveland Clinic study of over 120,000 patients found that low cardiorespiratory fitness was a stronger predictor of all-cause mortality than hypertension, diabetes, smoking, or kidney disease. Cardiorespiratory fitness slows organ-level protein degradation across multiple systems simultaneously. The third is sleep architecture, not sleep duration. Architecture, the proportion of time spent in slow-wave and REM sleep. Glymphatic clearance, the process by which the brain flushes metabolic waste, is most active during slow-wave sleep. Disrupted architecture accelerates brain-specific biological aging, independent of total sleep hours. Your biology is not fixed, but the window in which these mechanisms are most responsive is not infinite, and it is not the window most people believe it to be. The research consistently shows that organ-level changes begin accumulating in the 4th decade of life, not the 6th. The organs do not wait for you to feel old before they start aging ahead of schedule. The real question is what happens next, and what you do with the knowledge that the standard of care was never designed to answer it. The Northwestern study asked a question medicine had never formally posed. What if different parts of the same body are living in completely different years? The answer was yes. And it is measurable. And it has been measurable for some time. A follow-up analysis of the Northwestern cohort found that individuals with accelerated aging in 2 or more organs had a 6.5-fold higher risk of multisystem disease within 5 years compared to those with uniform aging profiles. That number does not come with a warning label at your annual physical. The system was not built to deliver that warning. It was built to respond to disease, not to predict it at the organ level, not to catch the decade of acceleration that precedes the diagnosis. You will not feel this divergence happening. The proteins change silently. The clocks run at different speeds. And the gap between what the science now knows and what gets measured in a standard physical examination grows wider every year the research advances. Most people will never know which of their organs is aging fastest.